Okay, so pay attention to this one. So what I'm going to do, I'm going to talk about tonight section 2.2 and 2.3. We hope 2.3 is the kind of application. We did it a little bit before, but we're going to get it through it. Okay, so what's going to be 2.2 first? Some formulas, okay, that help you to forget about the definition and just go with the formula. Okay, so we're going to call them basic because there are more formulas that we're going to see in future. So what's going to be basic? Rules of differentiation. So this means from now on, you can use the following rules to find the derivative of the function. Okay, you don't need any limit form. So what's going to be basic rules of differentiation? Okay, differentiation. That is going to be the case. Sorry, that's IATION. Rules of differentiations. Rules to find the derivative of the function. This is what's going to be about. Now, the first one. The first one is if you have a constant function, you see, and always remember, when we talk about derivative of the function, derivative is just the slope of a tangent line. So the first rule is if f of x is going to be equal to the c. C is a number. Okay, is a constant function. Is a constant function. We want to find what's going to be the derivative of the constant function. If you have f of x equal to 5, f of x equal to -2, f of x to the 1/2, 1/3, what is the derivative of this function? Okay, so just think about it. If I give you f of x equal to 5, what is going to be the graph of this function? F of x equal to 5, which is like y equal to 5. Can you tell me what is going to be the graph of y equal to 5? Any suggestion?
It would just be like a horizontal line.
Excellent.
Y equals 5.
Yes, very good. Horizontal line. If you have a horizontal line, what is the slope of the horizontal line?
Nothing.
If this is nothing.
0.
0. That's it. Yes. You see, if you have a horizontal line, you know that it's going to be rand rise. In this case, it's going to be all right. So the slope of a horizontal line would be 0. Remember, the slope is the same as the derivative. So this means if you have a constant function, the derivative of a constant function is 0. I mean, we can prove it with the limit formula, but that's easiest way to remember it, okay? So if you have a constant function, horizontal tangent line, the slope is 0. The slope is the derivative. So then f prime of x is equal to 0. It's going to be equal to the 0, okay, all the time. For all, okay, for all x. That's the rules number 1. Okay, f of x equal to 5, derivative 0. F prime of x equal to 1/2, derivative is 0. Okay, so the derivative of a constant function is equal to the 0. This is called the rules of the derivative of a constant function. That's the first one. Any question? The second one is the most important one. We talked about this one quite a lot the other night. So we are going to make it official. Remember the power rule. What is going to be the power rule? The power rule was action of differentiation. So what was that rule? That is it. If we have a power function, if f of x is equal to what? Is equal to the x to the n. Is a power function, means a power of the variable. Is a power function, then the derivative of the power function. Remember, we talk about action of differentiation is f prime of x is equal to, we talk about it, we bring the power down, remember, n x to the 1 down. We take out 1 unit, it's going to be n minus 1. Okay, so this is the one we call it power rule. Action of differentiation. Bring down the power, reduce it by 1 unit, that's it. Remember to talk about if you have f of x equal to the x to the 5th, f prime of x would be 5x to the 4th. And we give you all sorts of powers, positive, negative fractions, etc. So this is how we write it down. Derivative of x to the n prime n x to the n minus 1. That is power rule for any number n. Any number, okay, number n. It can be positive, it can be negative, it can be fraction, it can be a positive direction, okay? So if it is going to be positive direction, okay, and this is a positive power, whatever it is, we call it action of differentiation. We practiced this one the other night, so we're going to use it. Any question? So that is going to be the power rule. What's going to be the next one? Number 3. Number 3 is just like the limit. You say you have a function, f of x. Derivative would be f prime. Suppose you multiply the function by 2. If you have 2 times f of x, twice of the function. If you want to differentiate it, it's going to be 2 times the derivative. Okay, so if your function multiplied by 2, derivative would be multiplied by 2 first. If you have 5 times the function, 5 times the function, derivative would be 5 times the derivative of the function. Okay, so that would be again a useful formula, and this is how we're going to write it down. There you are. If f is differentiable, means you can find the derivative of the f, differentiable, and k is a number. K is a number. K is a number, then that's it. Then there you are. You see the derivative of k times f of x. So this means if there is a number in front of it, you see this one, x to the n. Suppose you have 5x to the n, 7x to the n. It doesn't matter. If you want to find the derivative, you keep that number as is. Then you find your derivative, k times f prime of x. It's like when you find the limit. Remember the limit of k times f of x with k times. So the examples that we discussed the other night was only x to the 5th, x cubed, x squared, but now it can have 5x squared, 10x squared, it doesn't matter. You keep the 5, okay, whatever number it is. So they call this one constant multiple of a function. So you have a function, you multiply by a number. So your derivative would be multiplied by the number 2. So if your function is going to be bigger, so the derivative will stay the same. Okay, so we're going to apply it in minutes and you will see it. Okay, so this is going to be useful. So we can put any number you like here and then continue. So in particular, if you like, the power rule would be changed into this format. If you have a number k times x to the n, if you want to differentiate it, we say the exponent times the coefficient is going to be k times n, x to the n minus 1. Okay, that gives us something better to be able to take care of it. Okay, so this, we just combine these two rules together to get this number. Okay, this is going to be, would the first n be a separate number? What do you mean by a separate number?
Oh, sorry, because I'm confused why there is like 2 n's at the end.
No, the first one is n, the other one is x.
Oh,
nx. This is the way I write the x.
Oh, okay.
Okay, that's fine.
All right, thank you.
So this is going to be the third rule. Now the fourth one would be interesting. What is the fourth one? Remember the limit of a sum of two functions. It's going to be sum of the limits. Remember the limit of f plus g. We find the limit of the f first, we add it to the g. It's the same for the derivative. So if you have two functions, okay, if you have two functions, if f and g are two differentiable functions, differentiable functions, okay? So you are able to find the derivative of f and the derivative of g. Then the functions, okay, the functions, the sum function, f plus g, and the difference function, f minus g, are also differentiable because the derivative is just a limit. And there you are. They call it adhesion rule. So if you want to find the derivative of sum of two functions, you see f of x plus a g of x. If you want to differentiate it, it's like the limits. You find the derivative of the first one, whatever it is, it's going to be f prime of x. And you add it to the derivative of the second one, g prime of x. That's it. So f of x, whatever it is, we can find its derivative. To find the derivative of the first one, we add it to the second one. This is if it's going to be the sum. It's the same. If it's going to be different, so it's a difference. There we are. This is going to be f of x minus g of x. So we kind of distribute it. So that gives us f prime of x minus g prime of x. So that's they call this one addition rule. Derivative of a sum of two functions is the sum of their derivative. Derivative of a difference of two functions is going to be difference of their derivative. There are three more rules. We talk about it later after the test, and then we're done. There is one rule for the product. Okay, the product of two functions, f times g. There is one rule for the quotient of two functions, f over g. There is a third one, which is a big one. We call it the chain rule. So that would be 2.4 and the 2.5, and we do these after your tests. So far, these are the rules of the game that we're going to have. Any question? Now we're going to apply it. That's it. We're going to apply it first as a formula, and then what's going to be the application? That would be 5 or 6 cases that we are going to be interested in. Okay, so let's see how we're going to apply each one of them. There you are. The first problem. Example. The first one, we just want to find the derivative of the function. That is going to be the first. Okay, so find the derivative of each function with those rules that we have. Find the derivative. Okay, the derivative of each function. Remember, you have the power rule, you have the the rule addition rule, and a difference rule, if you like. There you are. The first one, the most common one that we are going to use. This is it. F of x equal to the 2x cubed. Okay, minus 5x squared plus 7x minus 15. Minus 15. That's it. You see what we have is a sum and the difference of some function. It's a polynomial. So it's a combination of terms, okay? So 1, 2, 3, 4. I do the, just applying the theorem, then I give you, I tell you how when to write down the short form. So the solution is going to be officially, so it's going to be f prime of x. So we have to find the derivative of the first one. I write it down first, the 2x cubed. You find the derivative minus the difference rule, minus the derivative of the second one, 5x squared, differentiated, plus the derivative of a 7x, you differentiate it, and minus the derivative of 15. So I use the addition and the difference, okay, rules. Addition, because I keep the addition, and I keep the subtraction. Okay, question? Now, action of differentiation. What is the action of differentiation? We multiply the power by exponent, 3 times 2, 6, x to the 1 down. The power is 3, 1 down, 3 minus 1, that gives it 2. We're done with the first one. Okay, I just use the power rule and one of the rules, that the coefficient rules that we talk about it.
You did
Okay.
3 minus 1 to get the 2 right there.
That's it, yes. Always you subtract 1 unit. Okay, minus. The second one, do the same. 2 times 5, 10. 10x to the 1 done. This is 2. 2 minus 1 would be 1. We don't write the 1. Okay, so it will be 10x. Question? Next one, plus. Plus exponent times coefficient. 1 times 7 is 7. 7x to the, I write it down so that you know what's going to be the power when we get 1 done.
Would it be 0?
Would be 0, yes. We write the 0, then I simplify it. X to the 0. What is x to the 0? X to the 0. X to the 0 is 1 all the time. Anything to the 0 is equal to 1. So that's why we don't usually write it down. Okay, it's going to be 1 times 7, 7, x to the 1 down, that the power is 1. 1 minus 1 would be 0, x to the 0. Okay, minus, lift of 15. 15 is a constant function. Lift of the constant is 0. Okay, we talk about it. Constant function, y equal to 15 is horizontal line. So the slope is going to be equal to the 0. X to the 0 is 1, so this is it. F prime of x is equal to 6x squared minus 10x plus 7. The final answer. This is how you are going to write it down for us, okay? This is the most popular limits, and you're going to use it, okay, over and over and over. So pay attention to it. And we don't usually write the first part, and we do it right away. I'm going to give another one to show you. Any question? So you have to check the power only first. If there is going to be any radical, we're going to give you one, you change it. If it's going to be a fraction, you have to change it, because the only thing that you can do is just the power rule to get these numbers. Yes, what's the question?
So we don't need to put 7x because x to the 0 is 1, so it'll be just 7 times 1.
Yeah, it was 7x to the 0, but x to the 0 is 1.
Yeah.
That's
Okay, thank you.
okay. So this is how you do it quickly. You can do these operations if you like, but this is how we do it quickly. So suppose you want to do this one. 3x to the 4th, okay, 3x to the 4th minus 5x squared plus 7. Okay, this is how we do it. We do it just right away. It's going to be solution. You just check to see the powers. There is no radical, no fraction. So g prime of x is equal to the first one. Action of differentiation. Exponent times coefficient. 4 times 3, 12. 1 done. That's 4. 4 minus 1, 3. Done. Okay, minus the second one. 2 times 5, 10. 1 done. X to the 2 minus 1, 1. Divided over 7 is 0. And you're done. Okay, so this is the way in the short form that we are going to do it from now on. Action of differentiation, 4 times 3 is 12, 1 done, x to the 4 minus 1, which is 3. Minus 2 times 5, 10, 10x, x to the 2 minus 1, x, 7, 0. Because the derivative of a constant function is equal to the 0, and you're done. Remember, no simplification is possible. And this is going to be the case. Okay? This is going to be the case. 15 is a constant function. If the constant is 0. 15, 7. Remember, it's horizontal line. That's it. The slope is 0. Okay, any question? That's type 1. Type 1, easy, no changes, nothing. So it's going to be type 2. Type 2, you may have to do a little bit of algebra for us. You may have some radicals, some quotients, okay? So let's have another one. H of x is equal to, h of x is equal to, let's say, something like 6 radical x. Okay, 6 radical x minus 3 over x to the 5th plus 4x, okay, 4x, and this is going to be minus 9. And that's the kind that you are going to face for these type of problems. First thing to do, you have extra job. Remember we talked about the other night. The only formula that we have is the power rule. So we have to change everything into the power of the x. We talk about the radical x, you change it, you switch it. You switch it, remember, to the x to the 1/2. Then x to the 5th is down the denominator. So you move it up. I give you the formula the other night. So first thing to do, you have to get rid of any radical and you have to get rid of any fraction because the only formula is the power rule. Okay, so this is the first thing to do. We have to rewrite the problem. Rewrite it as h of x equal to 6x to the 1/2. Radical x, we write on x to the 1/2 because the index is 2, minus 3. We move this x to the 5th up, and you have to use a negative power. Okay, and that would be 4x, and this is minus 9. So that's going to be your first action because you don't have any formula for the radical, and you have to formula for the fraction. So you rewrite each radical into the power function, x to the 1/2 in this case, and you have x to the 5th down the denominator, you just move it up, make it to the negative exponent. Okay, question? Now apply the power rule again. H prime is equal to exponent times coefficient. You can multiply it and simplify it at the same time, but I prefer to write it down first. You see it's going to be 6 times. You keep the 6 as we talk about it. So action of differentiation, 1/2, x to the 1/2 minus 1. 1/2 minus 1 would be like 1 minus 2, which is going to be negative 1/2. Okay, 1/2 minus 1, you see 1/2 minus 1 is like 1/2 minus 2 over 2. So it's going to be 1 minus 2, which is a negative 1, negative 1/2. Or quickly, as we talk about it, is the 1 minus 2, the top minus the bottom one. That gives you negative 1. Okay, so it's going to be the first one. Then you come back and simplify it, of course. Next one, minus. Same thing over here. You know, we can multiply if you like right away, or just I explain it. I keep the negative 3. I bring the negative 5, x to the 1 done. It's going to be negative 5 minus 1, which is a negative 6. Okay, so that's going to be the second one. The next one, plus 4x to the first power. 1 times 4, 4. You see 1 done is going to be x to the 0, and we talk about it. X to 0 is 1, so we don't write it down. Okay, 1 times 4 is 4, 1 done, and nothing. So just 4. And the derivative of 9 is 0. The derivative of a constant function is going to be equal to the 0. Any question? You have to go back and simplify these fractions. Okay, this is going to be h prime of x equal to, this is going to be 6/2. Okay, 6/2 would be 3x to the negative 1/2. Okay, and over here, negative would be positive, plus 3 times 5 would be 15, x to the negative 6, plus 4. So that would be your final answer. Okay, so this is going to be a kind of most general problem that you're going to have, you know, for this section to get the radical. Any question?
For the solution on that one, wouldn't you then finish it off by putting it back into fractions?
No. I don't do it. You can do it for yourself if you like. And this is the end of the problem. If you want to do something else with this type of problem, we continue. Otherwise, nice, done. I know that in your proof they do it, but that's the algebra part. We are concerning with the calculus part. That's the final answer for this one. If we want to simplify it, we are going to give instruction. Find the derivative of the function and simplify it. Okay, so that was bit of one. But this is going to be the end of the problem for this type of item. We are going to have, of course, some other things that we do later in future. Then we go on. But that would be the algebra. Okay, so that's calculus. Exponent, you ask why I get negative 6. Is a negative 5 minus 1, negative 6. Anytime you differentiate, remember, you reduce the power by 1 unit. The power is a negative 5, it's going to be negative 5 minus 1, which is a negative 6. Okay, any question? So that's a kind of the most involved problems. If you want to make it a little bit more, and this is it. This is a kind of, not complicated really. The worst case from some point of view. And that's it. I give you all the things that we need. Let's see what is, some people, they miss a couple of signs for this one. Okay, let's see what is this. You see f of x is equal to, how about 12? Okay, cube root of x squared. That's one of them, minus. Okay, I got something like minus, let's say minus 9. It's going to be minus 9. And then I'm going to have something like, okay, minus 9. I get the fifth root of x down this denominator. Okay, down this denominator, and I have a, let's say 10 here. I want to find this derivative. It's not difficult, but you have lots of radicals, and you've got to be careful when you want to rewrite it. You have to rewrite it, you know that. You have to rewrite this power to be able to take care of it. Okay, are you ready? So let's see if we can rewrite it correctly. And then we differentiate it, f of x equal to, okay, we want to rewrite this one. Any suggestion? How are we going to rewrite it? To get rid of this radical. I say the 12 is going to be the 12. X to the, what's going to be the power of the x? Cube root of x squared.
X to the 2/3.
X to the 2/3, very good. 2/3, yes. You know that the index would go down the denominator, or any number is going to be 2. So it's going to be 12 x to the 2/3, very good. Minus, you see this one is the tricky one, 9 x to the, how about this one?
Negative 1/5.
Negative 1/5, very good. You see this is fifth root of x. When you change it, that gives you x to the a fifth, but it's down the denominator. So at the same time, you have to move it up. It's going to be x to the negative 1/5. Most of the people on the test, they usually miss this negative sign here. So you're going to be careful. You see this one is already up. So that gives x to the 2/3, 2/3. Minus 9 is the number, x to the, it's going to be down the denominator, it's going to be x to a fifth. But you want to move it up at the same time. It's a 2 action. It's a 2 action, so that would be 9x to the negative half plus 10. Now it is ready for the, okay, now it's going to be ready for action, if you like. So now our action would be action of differentiation. Okay, there you are. We get f prime of x is equal to exponent times coefficient. This is the coefficient, keep it 12 times it by, bring this one down, 2/3 x to the, you see 2/3 minus 1. It's like 2 minus 3, which is a negative 1. So that gives a negative 1/3. Let's quickly we find out. Okay, 2 minus 3 would be negative 1, negative 1/3. Now the next one is going to be negative 9. Now parentheses, action, bring the negative 1/5 down. It's a negative fifth. Okay, x to the. Now negative fifth minus 1 is like a negative 1 minus 5. It would be negative 6, negative 6/5. Okay, and you know the derivative of 10 is 0 because 10 is a single number. Okay, it's going to be just a constant. Okay, so this is how you take care of the powers. I repeat it again. It's going to be 12, bring the power down. It's going to be 2/3 x to the 1 down. It's a 2/3 minus 1. So it's a 2 minus 3, which is a negative 1/3. The next one's going to be negative 9x to the, then a negative fifth minus 1 is like a negative fifth minus 5, which is going to be negative 6/5, and the derivative of 10 is 0. Then you have to simplify these fractions if you can. It's going to be f prime of x. You see this one can be simplified. 12 divided by 3 is going to be 3, that would be 4. That's going to be 4 times 2, which is 8. There is a leftover. So that would be 8. Okay, that would be 8, and the x to the negative 1/3. Any question? So it's 12 times 2 is like 12 times 2, 24. 24 divided by 3 is 8, if you like. But we usually simplify and then we multiply. The next one, and the sign would be negative, negative, positive. So it's going to be positive. You cannot simplify, of course, this one. So it's going to be 9 times 1, which is going to be 9/5. Okay, 9/5, and the x to the negative 6/5, the final answer. Okay, this is the best you can have so far for the derivative of the function. Okay, you cannot have anything more complicated than this one at the moment. So the message is that you can only use the power rule. That's the step 1. So if you have a power rule, if you have a power function, you see, like the first one and the second one, no changes is needed, so we can do it right away. But if you have a radical expressions like the radical x or the third root of x squared, you have to rewrite it. You rewrite it into the rational power and carefully you take care of it to get this number. Any question? So that's problem number 1 for the test. We usually give you one problem, but it's going to be 2 parts. One part is going to be a couple of radicals, but the other part is going to be just one of those straightforward one. So this is how you practice. And when I post your practice test, number 1, you will see that this is the first question. Okay, question. Now, then that will take us to the application of these problems. Remember, as the question that I answered at the beginning, you know that derivative of the function is the slope of a tangent line, and that's when the story started. So we are going to make it into the application right away. So your first application is going to be equation of a tangent line. So we give a function and a point, and we would like to write equation of a tangent line. But you have to find the slope, but you have to find the slope by this type of formulas, not the limit. Okay. So that would take us to the next example. On the case of a tangent line, we are going to have 2 problems. Okay. So this is going to be the first one. So what is going to be the idea of this problem is tangent line equation. Okay, this is it. Tangent line equation. Again, a straightforward problem because we have the rules now. So the thing's getting shorter, if you like. There you are. It's going to be very standard. We give a function, mostly polynomial type at this level. So that's it. We are going to find the equation. Okay, find the equation. The equation of a tangent line. Of a tangent. Okay, tangent line to the graph. Okay, to the graph of what? Of the function. The graph of the function. Function is this one, f of x equal to f of x equal to the 2x cubed. 2x cubed minus 5x minus 1. Okay, at a point with the x coordinate of with x equal to -1. That's it. That's a tangent line problem. See, previously we did it, but in order to find the slope, we use the limit formula, but no more. You don't have to. We get this number right away. Okay, so you know that it's 2 steps. Step 1, you need a point. In your book, they give you x and the y coordinates at the beginning, but we don't. We just give you the x. So since we give you the x coordinate of the point, your first job is you drop it back into the function to get the y coordinate of the point. So you are going to have a point. So you don't have the point so far. Okay, so it's going to be the solution. Solution, the first step is you question yourself, what is the point or where is the point? Okay, I need a point. Do you have the point? No, you have only the x coordinate of the point. So we get x equal to the -1. Drop it into the function, you find f of -1. carefully substitute. Okay, over here you have to use parentheses, is going to be 2 times n negative 1 cubed. Okay, minus 5 times n negative 1 minus 1. Okay, we carefully substitute. Then negative 1 to the third would be a negative 1 here. Okay, so this is going to be 2 times a negative 1, negative positive, that give a positive 5, and the minus 1. So that give you a negative 2 plus 5 minus 1. So negative 2 and the negative 1, negative 3. So the result would be 2. Okay, so now we have a point. So our point, we call it the point P. The coordinate of this point is going to be negative 1, comma, negative 1, and 2. And this would be your first job, because we need a point to be able to take care of it. Okay, so this is going to be the case. So negative 1, you see negative 1 to the third, negative 1 to the third is a negative 1. So 2 times negative 1 would be a negative 2. Okay, negative, positive. Positive 5 minus 1. So that gives you 2. So that's a point. Any question? Now we need the slope. That's a step 2. What is going to be the slope of the line? Now this is calculus. The slope is the derivative. M is the derivative of the function f prime at what? At negative 1. So you have to find f prime of negative 1. Okay, now how are we going to find it? We find f prime of x first by the formulas that we have. We find f prime of x first, then we replace the x by negative 1. Okay, so you plug the negative 1 into the function first to get your point, negative 1 and 2. Then you go back, you repeat it again, but this time into the derivative of the function. That gives you the slope of a tangent line. Okay, so let's find out what's going to be the derivative of the function. So this is your function, and you want to differentiate it. Okay, so I rewrite the function so you know what's going on. So this is the function. There is no radical, okay, no quotient, so I can differentiate it right away. It's going to be f prime of x is equal to exponent times coefficient, 3 times 2, 6, 1 done, x squared. Okay, you have the 3 minus 1 would be 2. The next one, 1 times the negative 5 would be negative 5. The power of x is 1. 1 done, disappear, because that gives you x to the 0, and x to the 0 is 1. And the derivative of a negative 1 is 0. So that gives you f prime of x. Any question? 3 times 2, 6, x to the 1 done, 3 minus 1, 2, 6x squared. Minus 5x, derivative of 5x, 1 times 5, negative 5, x to the out. Because this is x to the first power, 1 minus 1 would be 0, x to the 0 is 1. And negative 1 is a constant. So you don't have anything for it. Okay, so that's f prime of x. Now find f prime of negative 1. So what's going to be f prime of negative 1? You carefully substitute. So use parentheses, 6 times the negative 1 squared minus 5. Negative 1 squared would be a positive 1. So that gives us 6 times 1 minus 5. It's a 6 minus 5, which is 1. So f prime of negative 1. Okay, f prime of negative 1 is equal to 1. And you know that the f prime is the slope. Okay, m is equal to the, so this means m, the slope of a tangent line, is equal to 1. Okay, there you are, we are ready. We have a point, negative 1 and 2, and we have the slope of 1. You know that y minus y1 equal to the m times x minus x1. Okay, I just remind you that this is the point P, is a negative 1 and 2. So that's going to be x1, that's going to be y1, and this is going to be m, which is equal to 1. So the formula that I'm going to use is y minus y1 equal to the m times x minus x1. You substitute y minus y1, which is a 2. M is 1 times x minus 1 is a negative 1. So put the parentheses here. So negative, make it to the positive. So that gives y minus 2 equal to, so it's going to be 1 times x plus 1. You distribute it, you see the 1 would drop. It's going to be y minus 2 equal to the x plus 1, and you add the 2, so y would be x plus 1 plus 2. Y equal to the x plus 3 is the equation of the tangent line. Okay, that is going to be the equation of the tangent line. You see, this is the way we do the equation of a tangent line. You're not going to use any limit formula or nothing, because now we have, we have those rules of differentiation, and we just apply the rules to get these numbers. Any question? So let's get a quick application of the derivative. You know that we invented the derivative just for solving this problem. Remember, solving the problem of a tangent line, and now we'll be able to nicely solve it. Okay, so this is going to be the tangent line problem, and that was our second problem that we talked about it. And now we are going to have another one for the tangent line. Okay, this is interesting, and this is going to be a procedure that we are going to use when we get to the next chapter for the rest of the course. But I want to give you something just to go on and think about it. You see, in this course or in calculus. In calculus, this is the tangent line. Okay, so we get the graph and we get the tangent line to your graph. But the thing that we're going to be interested in future, we are going to find something that we call it the maximum and the minimum. To get this one, just tell you what's the next problem is going to be. You don't have this one directly in your book now, but we would like to have it. So look at this one, this graph. This graph, you have a peak point here. We call it the maximum. And there's going to be a lowest point here that we call it the minimum. Okay, so what's the question? We get these two type of. What is that? Would there always have two equations to solve everything?
Sorry, I figured it out. I misread.
Okay, so that's one. Now, so look at this problem. So the problem that we are going to have is, we would like to find this maximum here. You know, in your case, it's going to be revenue profit. You would like to have a profit, maximum profit, okay? And this is going to be where you are interested in the cost, the minimum one. So for the following chapters in this book, we are going to identify this point. We are going to locate at this point. But this is calculus. You see, any problem in calculus, any problem from now on to calculus 1000. If you want to do any problem in calculus, you have to relate it to the tangent line problem. Okay, related to the tangent line. As I gave you the previous example, derivative means the slope of a tangent line. If you say the derivative of the function exists, means you can have a tangent line. So again, in order to find out how we're going to find the maximum point, the minimum point, you have to study the tangent line at these points. You see, if you draw a tangent line at the maximum point, you see this one is going to be horizontal. If you draw a tangent line as a minimum point, it's going to be horizontal. Okay, so that will tell you something. It will tell you that if you want to find where your graph, where your function, where your revenue function would have a maximum, you have to check where this tangent line is going to be horizontal. Now let's see what condition can be imposed to get this one. You see, it's going to be horizontal line. What is the derivative of horizontal line? Sorry, what is the slope of a horizontal line? The slope of the horizontal line?
0.
0, all your side, yeah. The slope of a tangent line would be 0. So we know that the slope of this line must be 0, okay? But this is algebra. In algebra, we learned that the slope of a horizontal line is 0, calculus. In calculus, we know that the slope of this line is f prime, remember? So this would be f prime of x. So the f prime of x, the slope in calculus, and the 0 slope of algebra must be equal to each other. So f prime of x must be equal to the 0 at this point. And it's going to be the same for this one. F prime of x equal to the 0. So that will tell you something. That if you want to have, at the moment, we are not going to talk about the maximum and the minimum. We talk about just a tangent line. But in future, really we find out that we're just talking about the maximum and the minimum, okay? So we want to practice before getting to that chapters. So we look at this and we say, oh, you may be asked, find the value of x where the tangent line to the graph of the function is horizontal. So find for which values of x, the slope of a tangent line would be horizontal. You say, oh, if the line is going to be horizontal, the slope must be zero. This slope must be zero. But this is calculus. At the same time, f prime of x must be zero. So in order to answer this problem, you have to solve this equation. F prime of x equal to 0. So you find f prime of x, you let it equal to 0, that would be an equation. You try to solve it by factoring. If your equation would have one solution, this means you have one horizontal line. If your equation would have more than one solution, you are going to have more horizontal tangent line. So this problem is going to be called the problem of horizontal tangent line. Okay, so I give you a remark. This would be the one that when we get to the rest of the course, we call it 50%, because any problem that you want to solve up through the final, you have to do this operation. And this problem would be divided in two parts. The first part is your action. So you get 50% of your grade when you do this type of problems in any problem in future. So I want to bring it up, okay, forward if you like. We talk about it. We're just checking your algebra before we get into those, to those time, if you like. So that's the idea of this problem. So I'm going to explain it, and I'll give you one question on this one. You're not going to wait. So that's the idea. If, okay, the idea is, let's give us a title. The title of this idea is going to be what? Horizontal. Okay. This is going to be horizontal tangent line. Tangent lines. So the other one was just the equation of a tangent line. But now we want to investigate to see where this horizontal, when this tangent line is going to be horizontal. And I talk about it, that give you the max and the min in future. So that's the problem. If y equal to the f of x is differentiable, means you can find the derivative. Okay, if this is going to be differentiable, then the derivative f prime, you know that would be the slope, is the slope, okay, it's going to be the slope of what? Of the tangent, of the tangent line, the slope of the tangent line at what? At x. So that's the definition of the derivative. Now, therefore, now this is the key. Therefore, if f prime of x would be equal to the 0, so this means the slope is 0. In that case, the tangent line is horizontal. Okay, if this is going to be the case, then okay, then the tangent line, tangent line to the graph of the function, to the graph y equal to the f of x is going to be horizontal. It's going to be, okay, that's it, horizontal at x. So the condition for having a horizontal tangent line is that f prime of x must be equal to 0. That's going to be the idea, okay, that we get it. Okay, any question? So we want to just keep on track, okay? That's the definition of the derivative all the time. Anytime you say derivative, just think about it, means tangent line. If they say the derivative exists, means there is a tangent line. If you find this derivative and happen to be equal to the 0, so the slope of the tangent line, the slope of a tangent line is 0, so you are going to have a, okay, you are going to have a horizontal, okay, a tangent line. So this is going to be our second problem. Now horizontal problem would be given. They give a function and they ask you to find how many horizontal tangent line are going to have. So this is the third problem of this section or this concept. So what's the problem? The problem is find the values. Find, okay, the values. Find the values of x where, okay, where the tangent line or lines, where the tangent, okay, where the tangent lines to the graph, okay, the tangent line to the graph of this function, of the function f of x equal to x cubed minus 3x plus 1 are going to be r horizontal. Horizontal. You see that's going to be the one. So in the previous problem, you were just interested in the finding the equation of a tangent line. But in this problem, you would like to check to see if you have a horizontal tangent line. Or if you have it, how many do you have? Okay. At what value of x? At some value of x, you may have only the tangent line. But at some value of x, you are going to have horizontal tangent. And we already talked about it. So this basically means, you see, you have to check to see when the derivative is 0. So in order to solve this problem, the only thing you have to do is you just simply solve this equation. Solve the equation of f prime of x equal to 0. Because we already explained it for you. That the condition that the line to be horizontal is the slope must be 0. But the slope of a tangent line is f prime. So you form f prime of x, you let it equal to the 0, and you use factoring method, sometimes quadratic formula, to be able to find the x. If you find the x, that x would create a horizontal tangent line. If you cannot find it, this means there is no horizontal tangent line, okay? So in this case, the problem is easy. So you find the f prime of x, this is it. Differentiate. Exponent times coefficient is going to be 3x to the 1 down, 3x minus 3 minus 1 would be 2. Minus 1 times 3 would be 3. X, the power of x is 1, 1 down, x to the 0, and that would disappear. And that give a result either way. Okay, question? That's f prime. Let it equal to the 0, solve it by factoring method. So f prime of x equal to the 0. So that would give us a 3x squared minus 3 equal to the 0. Different way to solve this one, you can use factoring, for example, factor out the 3, so that you x squared minus 1 equal to the 0. And then you factor again, x minus 1 times x plus 1 equal to the 0. The factors to be 0, 3 equal to the 0, never. So that's impossible. But x minus 1 equal to the 0, that give you x equal to, okay, x equal to 1, and x plus 1 equal to the 0. That would give you x equal to the negative 1. There you are. So you have two horizontal tangent lines. So at x equal to 1 and x equal to negative 1, okay, the tangent line to the graph of this function would be horizontal. In future, if we call these values, we call them critical values, because one of them would give you the maximum, the other one would give you a minimum. But not now. If you like, you can use this notation to get used to it. Critical values are going to be 2 points, -1 and 1. So at this point, you see if you graph it, this is going to be the graph of the function, and you get two horizontal tangent lines. You see 1, 2. One of them would give us the maximum. In this case, the other one would give us a minimum. Okay, any question? So I'm going to give another function because some people would have some difficulty in factoring. To just make sure that what you should look for the factoring case. Okay, it's a straightforward, but make sure that you solve that. Sometimes you may have to use quadratic formula to get these numbers. CV stands for critical value. Okay, in future, these are going to be called critical values, critical numbers, because one of them gives us the maximum, the other one the minimum. It's just, it's just a choice for the time being, but we just preparing you for future. Okay, to get these numbers done. So I'm going to give another one just to make sure that we get the algebra all right. Most of the time this is cubed. They may give something with a higher power. Okay, so let's check this one. This problem is going to be repeated. Okay, quite a lot. So why not? Let's check this one again. So again, you want to find the point. When we learn more derivative, more formulas, we're going to have a couple of more functions. But at the time being, for the time being, we just can work with the polynomials only. Okay, nothing, no fraction, nothing. Okay, find the. We want to find. That's it. Find the values. Same thing. Find the values of x where the tangent line. Okay, when the tangent lines to the graph. Okay, to the graph of this function. Okay, the function is f of x equal to, this must be something like x to the fourth. Okay, this would be x to the fourth, and this is going to be minus 18. Okay, that would be minus 18x squared. Okay, minus 18x squared and plus 1. That's it. The factoring method is going to be interesting for this one. Okay. So we want to find the values of the x where the tangent lines to the graph of this function are going to be horizontal. Okay. Horizontal. Okay, that's it. Again, if we already talked about it, tangent line would be horizontal. If the slope is 0, the slope is f prime. So basically what you are going to do for us is what? So the solution is, you have to solve this equation. Solve the equation of f prime of x equal to the 0. Carefully differentiate it, and then use a factoring method to solve that equation to find the critical values if you like. Okay, differentiate it. F prime equal to action of differentiation, we bring the power down for x to the 1 down, that's a 4 down would be 3. The next one minus action of differentiation, 2 times 18 would be 36. And the power would be just x. Okay, for x cubed minus 36x, divided of 1 is 0. Question? You let it equal to 0 because you would like to have the horizontal tangent line, so your slope must be 0. So f prime equal to the 0. So you have the equation to solve. So that would be what? That would be 4x cubed. Sorry, 4x cubed minus 36x equal to the 0. You have to solve this equation. You have to find the common factor. If there is anyone, okay, what's the common factor for this one? Any suggestion?
4x.
That's it, 4x. So 4x out. Okay, 4x out, that gives us x squared here minus 9 equal to the 0. Okay, now we can factor x squared minus 9. So that will give us a 4x times x minus 3 times x plus 3 equal to 0. Okay, now you have three factors. You see 1, 2, 3. So three factors, three numbers, for x equal to the 0. You know that for x equal to 0, x would be 0. Because you divide by 4, you see it would be x equal to the 0 divided by 4, which is 0. So we get x equal to the 0, one number. Any question? I've given a similar one on the test. Some people, they drop the x, they cross out the x, and they say, oh, I divide by x. Remember, you cannot divide by x. You have a pizza, can you divide by x? No. So you don't divide it because you don't know whether x is 0 or not. Besides, x equal to 0 is one of your solutions. So if you drop the x, you will drop one of the tangent line, okay? So the previous problem that I did was 3, not the 3x. Look at this one. You see the coefficient here? That was just 3 equal to the 0. 3 equal to the 0, never. But over here is not 3. It's 4 times x. 4 times x equal to 0, x would be 0 over 4. So x equal to the 0 is one of the solution. So don't miss it. That's going to be the 1. So that is going to be 1. How did I get x squared minus 9? Just divide. The factor of the 4x, you see divide, x cubed divided by x, that gives x squared. 36 divided by 4, that gives me 9. That's x squared minus 9. Okay, so we continue. We have two more factors, x minus 3 equal to the 0. So that gives x equal to 3, the other solution, the second one. X plus 3 equal to the 0. So that gives us x equal to -3. So we are going to have 3 horizontal tangent line, and for future, 3 critical values if you like. It's a -3. It's optional, to write it down. Just want to keep in mind when we get to this one in the following chapters, you know that what we were preparing you. Okay. So this is going to be the case. Okay, it would be a very popular case in future. You see, this is going to be the graph of this function. It's a kind of this one. When we graph it, this is going to be the function. So as you can see, you are going to have 3 horizontal tangent lines. You see 1, 2, 3. And for future, you see the 2 minimum, 1 maximum. That's why this problem is very popular in future. Then they ask you to find the max and the mean, and this is going to be a first step. The big one, the main part, especially solving these type of equations, okay? So we're just checking factorings and getting this equation and getting you prepared for future. Okay, any question? So that's a problem of a tangent line. Remember, 2 problems. The first one is going to be writing the equation of a tangent line, not a big deal. We completed, this is the one that we did. We complete the coordinate of the point. We get the point, -1, 2. We need the slope. The slope is derivative. We find the derivative of the function. We substitute. We get the slope and the point. You write it down. The next problem, important one, is this one. Problem of a horizontal tangent line. We know that the line is horizontal if the slope is 0. But this is okay. But this is a tangent line. The slope of a tangent line is the derivative. So the derivative must be 0. So we find the derivative below equal to 0, get these numbers. Okay, that will take us to the application point. I give you a break for 10 minutes. Okay, it's 8:30. We come back and then we are done. This is 2.2. So in 2.3, we have to talk about the rate of change. We already talked about it. So we are going to put it into the format of 2 problems, and that give you those 2 problems. And that's the 6 problems that I promise you that you are going to have from these sections. Okay, then we're done and we prepare for the test. Okay, 10 minutes and we come back and we finish it. Okay, so that was a kind of application of the derivative from 2 point of views. Okay, the slope, and the other one is the the horizontal tangent line is going to be used in future to get the maximum and the minimum. Now we are going to continue to give you two application in everyday life. We already talked about it. Remember, we talked about rate of change, average rate of change the other night. Average rate of change is like the slope. And then we have the rate of change at any time. And that we describe it to be derivative of the function. So there are two problems that we're going to investigate. One of them is about the average velocity and the instantaneous velocity that we talked about before. And then the kind of cost function. We did this problem before, but we didn't have the rules to be able to get it through. Now we have it, okay? So that's the idea of section 2.3 that we did everything before. So this is going to be our second example, next example. And that's a problem number 4, if you like. So this problem would be about rate of change. Okay, this is going to be just a rate of change problem. And we are in 2.3. So we talk about one problem from physics. So we give you one, although you are a business major. So we may give you one just to understand the concept, or we may not. Okay, depends. But we are going to check it because you have to solve your problems, your assignment. Okay, that's it. Suppose f of t is equal to the 3t squared, okay, minus 5t plus 10. So this is going to be the position. Remember, we talked about you driving on freeway, and this is going to be your position. Okay, suppose this is going to be the position. Okay, this is going to be the position of a moving object, okay, of a moving object. Moving object, it's going to be in miles. Okay, in miles after t hours. So after t hours, it's going to be, you are going to be at this point if you want to find out where are you. Okay, replace t by 2 hours. So f of 2 would be how many miles are going to be from home after 2 hours to get these numbers. Okay, so this is going to be the case. What is what? Was the last problem a wave function problem? No, the last problem was just a tangent line problem. Okay, we can relate it to any problem in everyday life, but for the time being, we just call it the and we call it just tangent line problem. Okay, so this is it. F of t is the position of a moving object after t hours. Then we want to find two quantity for us. Okay, quantity is the first one. Find the first part. We would like you to find the average velocity. Okay, find average velocity. Average velocity is just the slope or of the the slope of a secant line of the object. Okay, of the object over the interval. Over the interval 1, 4. Okay, so that's going to be the first part, average velocity. And the other one was just the actual velocity at any time we like. So the next one is going to be, they call it instantaneous velocity or just the velocity. What is the velocity? What is the velocity of the, of the object? Of the object after, after 3 hours. So the first one is going to be your average velocity. You drive on freeway, your average velocity is going to be Okay, 60 miles, 65 miles. But the second one is going to be a velocity at any time. Okay, so this is a kind of comparing the definition of the derivative of the function as we did it. So we talked about this for you the other night. So the solution is going to be for the average velocity. Remember, we talked about it. The average velocity, this is it. It's just like the slope, y2 minus y1, the slope of a line. y2 minus y1 over x2 minus x1. So you want to find the average velocity. Interval is 1 and 4. So this is going to be the formula. A displacement of a distance, f of 4 minus f of 1, and a difference of the times. So that's the average velocity. Okay, f of x2, we give you the formula the other night. F of x2 minus f of x1 over x2 minus x1. So what you have to do, you have to go back to the function, find no derivative for this part, okay, no derivative. So we have to find the f of 4, f of 1, come back, substitute, simplify, that give you the result, okay? So we go to the function, we plug in, okay, plug in to get the f of 4. So this is going to be f of 4. Okay, f of 4 equal to the substitute is going to be 3 times 4 squared minus 5 times 4 plus 10 into the function. Carefully simplify it. It's going to be 4 squared is 16, so it's going to be 3 times 16 minus 20 plus 10. So that gives 48 minus 20 plus 10. Okay, what's the result? 48 minus 20 would be 28, 38. So that would be 38. Okay, so that's going to be f of 4. This is your distance after 4 hours. Okay, your position, 38 miles. Find f of 1. Okay, so you are going to find the f of 1. So for finding the f of 1, you just substitute, replace the t by 1. So that give it 3 times 1 squared, okay, minus 5 times 1, 5 times 1 plus 10. Okay, so this is going to be the case. Now we simplify it, okay? So we simplify it, we are going to get what? It's going to be 3 minus 5 plus 10. So that's what is going to be negative 2 and 8. So that give you the 8. Okay, 38 and 8. So come back, get it down here. So what we're going to have is going to be f of 4 minus f of 1 over 4 minus 1. Okay, we got the f of 4. What's f of 4 is going to be 38 minus f of 1, which is 8. And that was the 4 minus 1. So it's going to be 30. It's all algebra over 30, and the result is going to be 10. Okay, it's going to be 10. There must be a unit. What's the unit for this one? This is velocity. Any suggestion? Remember your distance, you have the distance and you have the time.
And miles?
Miles and per what?
Miles per hour.
Miles per hour. Okay, it's going to be miles per hour. Remember, you have to give us the unit for this problem, okay? So the unit is going to be miles per hour. Yes, you're right. Okay, any question? So don't miss it. That's the first part. Very easy case. That's going to be average velocity. Okay, we can give you a cost function and we ask you what's going to be the average cost. Okay, but since in your book they give you one example from physics, one from business, so why not? We just give you one from each. Okay, so don't miss it. No derivative involved because this is the average. From a geometrical point of view, you just find the slope of a secant line, not the tangent line. Okay, that's first part. Question? Now the second part. You see, instantaneous velocity or just the velocity. Remember, I talked about when you be given a ticket. Okay, instantaneous velocity is just exactly at the time that the camera would get you to give you a ticket, okay? Register your velocity. That is going to be given what? That would be the derivative of the function. So the velocity or instantaneous velocity is going to be, you see, they ask what is the velocity, means the derivative. What is the derivative of the object after 3 hours? Means the derivative at 3. So in this case, you see the velocity, the velocity is going to be what? Is going to be the derivative of the function after 3 hours, f prime of 3. So make sure you know a difference between the first part and the second part that you're going to have. Okay, any question? So this is it. Don't miss it. So what you are going to do, you have to find the derivative of the function. You find the derivative of the function and then you replace the t by 3 and you're done. Okay, so bring the function f of t is equal to 3t squared minus 5t plus 10. Differentiate it. Easy to differentiate. Any suggestion? What's the derivative of this function? What's f prime of t? F prime of t?
6t minus 5.
Excellent. 6t minus, okay, that's it. 6t minus 5. That's f prime. You wanted at what? At 3 hours. Substitute. So f prime of 3 is going to be 6 times 3 minus 5. 6 times 3 would be 18. 18 minus 5, which is equal to the 13. So the velocity after 3 hours is going to be, okay, 13. You know, the unit is going to be the same unit, miles per hour. So this is it. So that 10 miles per hour is going to be your average velocity. Okay, average velocity must be given in the special period. You see the period between 1 hour and the 4 hours. You see between 1 and 4. For the average, you always need a range, if you like. But for the instantaneous velocity or just the velocity, that's the specific time. So for the specific time, remember this derivative is rate of change. It's rate of change of what? Rate of change of, this means actually after 3 hours, your velocity would be increased at the rate of 13 miles per hour. So that's the meaning of the derivative that you're going to have. Okay, is the rate of change that you're going to have. Any question? So don't miss it. It's easy problem. I've given this one several times on tests, not only on your case. In calculus 1, 2, 3, I've seen some people, they just don't touch it. When I ask why, they say, I don't like word problem. What are you talking about? It's not a word problem. You say it's everyday life problem. That's the essential of the course, if you like. And besides, it's very easy. You see, this is going to be a kind of easiest problem in any test. So get to know them, enjoy that, okay, compare it with, different cases that you're going to have to give you the feeling that what are you doing really with this old derivative, finding the slope. These are just excuses, you see, this slope or secant line. This is the real life, okay? So pay attention, and besides, you get a good grade. Otherwise, you enjoy the course and you understand it. So that is the first case. Any question? You have a couple of them in your assignment, so now you know how to do it. So this is from physics. The other one from business. Okay, we are going to give you some. It's going to be similar. It's going to be the cost function, revenue function at this level, and we ask you a similar question, and you have two nice one in your practice test. So let's check this one to see what is going on. So that was the fifth problem I promised you, and this is the sixth one, the last one. Study this one carefully. You have 6 on your practice test. We go over it on Thursday, and you have 6 on your take-home one. So you are going to be ready for the 6 of this type on the, okay, on the test number 1. Okay, so this is it. Next example. Next example from, okay, from business. In business, they usually, I'm going to talk about this one again later on. They don't use the term derivative, okay? I'm going to use the derivative for the time being. But in business, instead of derivative, they use the term marginal function. So if you have a cost function like C of X, C prime of X, they call it marginal cost. We get back to this one, so don't worry about this expression. If you see it, I'm going to put it in that practice one and explain it. But basically that problem is going to be this one. It is again rate of change problem, but for other type of problem, rate of change. So one from physics and one otherwise, which is going to be business. This is it. Now, what's the situation? This is the situation we'll be given to. We did this problem the other night, but we didn't have the tools to evaluate it. I just give you 2 numbers. But for this one, you have to find the number yourself. So what's this? We have the cost function. Suppose the total cost function, there you are, the total, that's it, the total cost, of course, in dollars. Okay, the total cost in dollars of producing. Okay, of producing X number of cars, X number of cars, X number of car is given. Okay, is given by this formula. Cost equation. C of X is equal to 5x squared minus X plus 10,000. Okay, so this is the total cost of producing X number of cars. So that 2 questions that we proposed the other night, but I just give you the result, but now you're going to do it yourself. The first part, we wanted to evaluate C of 50. Means you replace the X by 50. C of 50, and tell us what does it mean. And okay, and explain its meaning. In word form, you have to tell us what does it mean. That's the first part. The second part, we wanted to evaluate C prime of 50. They call it marginal function, okay? But for the time being, we just go with the prime, C prime, and then again explain it. And you are going to explain its meaning. Okay, C of 50 and C prime of 50. You tell us what's the difference between the first one and the second one. Okay, are you ready? The first one, just substitute. Okay, plug in X equal to 50 and simplify it. So that would be the solution. Okay, solution, part 1. Part 1, we would like to find C of 50. What's going to be C of 50? Substitute, replace the X by 50. It's going to be 5 times 50 squared minus 50 plus 10,000. Carefully simplify. 50 squared would be 2,500. Okay, so it's going to be equal to the 5 times 2,500 minus 50 plus 10,000. Go on. It's going to be 5 times 25 would be 125. 2 zeros minus 50. Okay, plus 10,000. Okay, combine the like terms. What do you have? We have a 10,000 over here, and this is going to be that is going to be 12,050. So it's going to be equal to what? Is equal to 10 and 12 would be 22. So that give you 22,500. Okay, minus 50. Minus 50. So this is going to be C of 50. You subtracted, of course, this is money. If you subtract it in dollars, how much do you have? It's going to be $22,000 and 450. This would be C of 50. Okay, carefully simplify it. Use your calculator. Make sure that you get it. Okay, you get it. You get it all right to get these numbers. Okay. Any question? So describe it for us. What does it mean? C of 50. Any suggestion?
It costs $22,450 to produce 50 cars.
Excellent. That's it. That's going to be the total cost of producing 50 cars. Okay, or it costs, yes, you are right. Okay, because that was a total cost function. So you have to write something nice. Okay, different way to do it. This is like what I did. A total cost of producing 50 cars. 50 cars is what is going to be at $22,450. And we're done. Okay, that's part one. Any question? So the part one is the actual cost. You see, that's the actual cost, exact, because you have your formulas and you use your calculator. Now C prime, the second part. In the second part, you know that you have to find the C prime of X first. C prime of X differentiate. This is it. This is your function. This is going to be your function. You are going to differentiate it. So this is going to be our function. C of X is equal to the 5x squared minus X plus 10,000. Differentiated. What's the prime of X? C prime. Differentiate.
Is it 10x minus 1?
10x minus 1. Yes, you are right. Thank you. Very good. 10x minus, you know that exponent times coefficient, 2 times 5, 10, 1 done, 10x. Minus 1 times negative 1 would be negative 1, 1 done, nothing. Because the power of x was 1. And the 10,000 derivative is 0. Okay, that's going to be C prime. But now we want C prime of 50, so substitute. What's going to be C prime of 50? C prime of 50, your substitute is going to be 10 times 50 minus 1. Okay, 10 times 50 would give a 500. Okay, it's going to be 500 minus 1, which is going to be what? It's going to be 499. Okay, so this is again dollars. C prime of 50 would be in dollars. Okay, it's going to be $499. Okay, so the functions are not going to be complicated one because we cannot find the derivative of the function. Okay, so this is going to be $499. Any question? Remember, this is C prime. What does it mean? Remember, C prime is rate of change. It's not average. Something nice for this one? Remember, we talk about C prime is prediction.
The cost of each additional car over 50 is $499.
Yes, that's nice. That can be true. Yes, it's true. Yeah, you can say that the estimate cost, not just the exact cost, because this is C prime. Yes, this is one way to do it. Any other suggestion? kind of format of the rate of change to explain it for us. You see, C prime is a prediction. So what is this is going to be predicted for us? You see, C prime of 50. 50 is the level of production. So this means we already produced 50 cars. Now, if you want to go on, and producing the next car, if you like, if you want to produce the next car, it costs you more money to do it. How much? That's it, $499. So one way to do it, you can say that after producing 50 cars, okay, because you have to tell us what is the level of the production. That's important. After producing 50 cars, the total cost, this is a positive number. So this means increased. So after producing 50 cars, the total cost will be increased at the rate of $499 per car. That's the best way to describe it. You see, you exactly tell us what would happen for the future. Of course, you are right, because this is you already produced 50 car, you want to produce the next car. So you want to know how much more are going to cost you. This is it. This is going to be an estimate. You must emphasize on the estimate. It's not exact. You can emphasize that after producing 50 cars, the estimate cost of an additional car or the next car is going to be $499. Okay, so either one would be fine and be accepted. But if you want to use you have to use the estimate, because when talk about C prime is an estimate. When talk about the C is exact. Okay, in the problem of your book, they use these two expressions, both of them together. Okay, so one way to do it, this is going to be the case. I like this format, but anything close to it will be accepted. But you have to give us the level of production after producing 50 cars at this level of production. Okay, the production cost, or total cost, the production cost, this is a positive number, so it would increase, will be increased. It costs you more. Increase at what rate? At the rate of, okay, at the rate of $499 per unit per car. So that's the best format that would be connected to the rate of change. The cost to produce each additional car, yes, that's true. Charles, yes, you're right. So yes, you can say that equivalently, if you like, the one that I've seen some people suggested, it is going to be the case that, again, you have to tell us the level of production. You can say that at the level of production of 50 cars, or after producing, you must give us a level. After producing 50 cars, okay, the cost of producing the next car, an additional car, an additional unit or car, is going to be approximately car is approximately what? $499. Okay, this is two different versions of this, this problem. There is a third part for the problem of some of the problem in your book, and we have one of them on that practice one. They want to confirm it. Okay, so this is an estimate cost. Then they ask you, oh, what is the exact cost? Okay, what is going to be the exact cost of the producing an additional car? Any suggestion? You know which car is this one? That additional car. Remember the level of production is 50. Yes, the 51 or the 51st one. So C prime up, and this is your estimate that you're going to have. But if you want to find the actual cost of the production, what are you going to do? Any suggestion? This is the estimate of cost of additional car, which is going to be C of 51 or 51st one. So how about if you want to find the exact cost of the next car? Any suggestion? The exact cost of producing, unit production cost plus no, that's the estimate cost for the next car. The next car is 51st car. You see, my question is this one. You see, this is estimate cost of, you see, this is just for your information, estimate cost of the 51st car. Okay, so the 51st car, it costs approximately $499. So if you want to find the exact cost, not the estimate, will you put 51 for X in the formula? No. No. What is C of 51? What's the meaning of C of 51?
The cost to produce 51 cars. The total
Excellent.
cost.
Excellent. So what is C of 50? Let me write it down here. So what's the question? The question is, you have it, as a part 3 in your book. So what is the exact cost of 50, cost of production, cost of producing the 51 or 51st car. First car. You see, this is, that C of 51 is the cost of producing 51 car minus total cost minus C of 50. You see, C of 51 is the cost of producing 51 cars. C of 50 is the cost of producing 50 cars. If you subtract it, that gives you the exact cost of producing, okay, 51st car, if you like. And it's not that difficult to find it. You see, you can use your calculator to check this one. So C of 51, you go to the function, and this is going to be 5 times 51 squared minus 51 plus 10,000. Okay, you can use calculator to find this one. It's not going to be difficult. What's going to be 50, if you use your calculator to get this number. So we have what, 51 times 51 and 2601, and you multiply it by 5. So that would give us, this is the number 13,005, and this is minus 51 plus 10,000. Okay, so I added to the 10,000, 1, 2, 3, 4, and then I subtract the 51. And this is going to be the number. So the total cost of producing 51 car is going to be 22,954. So this is the cost of producing 51 car, remember? And we did have C of 50. We find it in the first part. C of 50 was, okay, it was 22,450. Okay, if you subtract it, so C of 51 minus C of 50 is going to be what? So it's going to be 22,954 minus 22,450. If you subtract this one, you see that's going to be 22,450, and the number would be almost the same. It's something around $504. So that gives you C of 50, which is going to be, you see, that's going to be the one. And remember the C prime of 50, your C prime of 50 was what? Was almost $500. So they are almost the same. So C prime of 50 is approximately the same as C of 51 minus C of 50. In some problem in your book or the one that you have on your practice one, they want you to confirm it, if you like, to confirm that your estimate and the actual one is going to be exactly, almost the same as each other. Okay, so that gives you a better understanding that what we are talking about when you talk about the rate of change, that the derivative of the function is just a prediction. Yeah, of course, that was easier to find. C prime of 50 easy. Cost of additional one is $499, which is almost 500. But if you want to find the actual cost, exact one, this is the exact one. Total cost of producing 51 cars, C of 51, the cost of 50, C of 50, you subtract it, that give you the exact. So the derivative give you an estimate and the formula an estimate and exact, but they are going to be the same. Okay, any question? So that give you the nature of these type of problems in application that you get it for you can have it for the cost function, revenue function. For some, it depends on, you can do it in biology, okay, in chemistry, in physics. The physics is going to be just the velocity. So this is the kind of application that we are going to be interested in. Any question? So we are ready for test one. Study this problem carefully that I give you tonight and make sure you understand that. Okay, you don't have to memorize it. A couple of them are just memorizing. But these last two, the physical one is easy, it's just we cannot do anything about that one, moving object is the same. And this part, again, the first part, the second part is the same. Sometimes they put something together, to get to, we may ask for the exact comparison or not, but we are ready for it. That's it. So we are done with section 2.3 and we are ready. Okay, we are ready for the test. So I will review that.